Good day to you. This is teacher Leland, Alejandro, and we're going to discuss now writing linear equations. And we're going to write the equations based on given conditions. Okay, let us see the problem set for our discussions. Okay, it's in the other screen. All right, here. Now let us see how many. Okay, we can check it out first. Okay, we have about, this will be about 12, okay? 12 examples. All right, let us begin with the first number. Let us begin with the first number. Okay, here's the first number. Okay, here's the first number. Solve for the following linear equation problems. Here's the first number. The given line contains the points 0, -4, and 3, -2. What is the equation of the line that is parallel to the given line and passes through the point -3, 1? Write your answer in slope-intercept form. All right, slope and intercept form. Now, the slope-intercept form has this form. Y is equal to mx plus b. Yeah. So there's a slope and the y-intercept b. This is the slope-intercept form. Now, before we can do this, we need to make use of the slope of the given line and then use the point -3, 1. Okay, -3, 1. So, and then transform the equation into this form. There. That's how to write the equation in this form. So let us have the given. Okay. So the given line here has its 2 points, and here is one of the points, 0, -4. And we can denote this as our point 1. Okay, point 1. And if this is our point 1, then we can label this x1 and y1. Let's consider the other point 3, -2. And this is x2 and y2. x2, y2. All right, so we will have the slope here. We can compute the slope because parallel lines will have the same slope. And so we can compute for the slope first and then use the -3, 1. So we can use the slope formula. And this is y2 minus y1 over x2 minus x1 there. All right, so y2 is -2 minus y1, which is -4. And this is to be divided by x2, which is 3, minus x1 happens to be a 0. So this will continue like -2, minus minus, or minus negative, that becomes plus. And this will become +4. And this is to be divided by 3 minus 0 is just 3. And this will now be 2/3. 2/3. So we have the slope. We can now use the point -3, 1. -3, 1. Now let's consider this -3, 1 just our point 1, okay, again, all right, so that we can denote is -3, 1, our x1 and y1, so that we can use this in the point slope form equation because we have a slope now and we have the point that we're going to consider. Okay, so we can use the point slope form, and this is the format. Y minus y1 is equal to slope m times x minus x1 there. So this is y minus y1. This will become y minus 1 which is equal to m, which is our 2/3 multiplied by x minus x1. Our x1 is -3. So after the minus in the formula, this will be a -3 there. And so this form of the equation is what we call the point slope form. This is not the required. The required is slope-intercept. According to the last statement, write your answer in slope-intercept form. We have this equation, but this is not the required form. So we still have to transform this to this format. Y is equal to mx plus b. So this will involve now algebra. Okay. So this will be 2/3, and this minus negative will become plus. There. And this is y minus 1 equals there. Now distributing the 2/3 into the x and into the 3, the right side will be 2x over 3. And then, of course, 2/3 times 3, that will just be 2. Because that will become 2 times 3, 6 over 3. So 6 over 3 is 2. The left side is still y minus 1. There. And then to continue this, we will just add 1 to both sides. Okay, we will add 1 to both sides. And this will become y minus 1 equals 2x over 3 plus 2. So we add 1 here and we add 1 here. And this will now be y. The -1 plus 1, that gives us 0. And then the right side simplifies to 2/3 x plus 3. There. And this looks like the required slope-intercept form. All right, we can verify the answer and check it out. There. It's over here, a very tiny answer over here. Okay, let me make my circle better. All right, there. Y is equal to 2/3 x plus 3. Exactly what we have in our answer. So that gives our first number. Let's continue with the next. All right, let's continue with the next. Let's have the second. Okay, here's the second. The given line passes through the points 0, -5, and 3, 2, as indicated in the red points. Okay, you can notice that 0 and -5 and 3, 2. What is the equation in point slope form? Point slope form of the line that is parallel to the given line and passes through the point -3, -1. So what is this point slope form? Okay, the point slope form is this. Y minus y1 is equal to m, that's the slope, multiplied by x minus x1. There. Okay, so y minus y1 is equals to m times x minus x1. So in this particular required equation, we need the slope m and the point x1, y1. Okay, x1, y1. And the x1, y1 will be this point here. Okay, now temporarily, we're going to make use of the given 2 points to compute for the slope m. So we can use x1, y1 in one of the given points, okay, just to get the slope, and so that we can use the formula for the slope, okay, and then that will be used in this formula, okay. All right, so that's the way to do it. All right, so let us get the given first. So we have 0 and -5, and we have 3, 2. And this is something we can apply in the labels. So let's take this as our x1 and y1, and take this our x2 and y2 there. All right, so we can compute for the slope. Okay, so the slope is y2 minus y1 over x2 minus x1. All right, so this will now be y2. Our y2 is, from the labels, you can see it's 2 minus, okay, that's part of the formula, the minus. Now, y1 is negative 5. So right after the minus in the formula, we have to write negative 5. And then we have x2 minus x1. x2 is 3 minus, all right, x1 is 0. And this will continue like 2 plus 5. That's minus minus, that becomes plus. So we have 2 plus 5. And this will be over 3. And so our slope, the required slope is 7 over 3. Yeah. So this is our slope. And since we're after a parallel line, we're looking for the equation of the parallel line to this line. So it will have the same slope, 7 over 3. Okay, now we're ready to use this formula. Okay, there. And we will have to make use of x1, y1 for our given point. Okay, for our given point. And we can use it in this formula there. So our given point is negative 3, negative 1 in the third quadrant. So this is negative 3, negative 1 in the third quadrant. So this is x1, y1 there. All right, using now the slope and this point, okay, all right, this will now be y minus y1. Our y1 this time is a negative 1, so after the minus, it's a negative 1, equals the slope 7 over 3 multiplied by x minus the x1. Our x1 now is the negative 3. Remember, we're using this point, okay? All right. Now, the x1, y1 a while ago, it's just temporary, just for us to compute for the slope. So we use again the label x1, y1 for the given point where we are going to pass the parallel line. So this is the established line, and we will just simplify it. Y minus minus 1 is equal to 7 over 3 times x minus negative 3. So this will now be minus negative. Remember, that will become plus. So this is y plus 1 is equal to 7 over 3 x plus 3 there. And this is the required form, point and a slope form, okay? And this must be the required answer there. Okay, so we shall see the answer after a little while. All right. So this is our answer. And let's see where the computer will write the answer. Oh, it's over here on top, okay? It's over here. So we shall erase that formula that I wrote so that it can be displayed clearly. All right, let me just clear this part here. There, okay? Okay, now let us display the answer. There, okay? So you can see the answer over here. There. Y plus 1 is equal to 7 over 3 times x plus 3. There, okay? So that goes to our second number. Let's continue with the third. Let me clear the screen for the third number. And we shall proceed to the third. Okay, here is the third, okay? Here's the third. We can slightly increase that so that it will look larger. All right, what is the equation of the line that is parallel to the given line? Okay, parallel to the given line and passes through the point 5, negative 3. So 5, negative 3 is this point here. There. That's the 5, negative 3. That's located at the fourth quadrant. Now, The horizontal line, this particular constant function is equivalent to y uh, equal to the number at the intercept, okay, y-intercept. The y-intercept here is at 0, 5, right here. Zero, 5, okay? And so this particular line, this blue line is y equal to 5, okay? Y equal to 5, okay? And we were able to write the equation this way because the y-intercept is 5, and all the values of the points on this line will have a value of y 5, okay? So the name of this line, okay, is y equals 5. Now, going to the given point, 5, negative 3, the y value there is negative 3. So the line here is y equal to negative 3. There. That's the answer. Y equals negative 3. That's the answer. Okay? And that is supposed to be a perfect horizontal. Perfect horizontal. So it will have to be this. There, like that. Okay? And that is supposed to be y is equal to negative 3. All values of the points there will have different x values, but the y will always be negative 3. Okay? So the answer here is y is equal to negative 3. And you can see that over here. There. Y is equal to negative 3. So if lines are perfect horizontal, it's y equal to a constant. Okay? Y equal to a constant. And I can show you some examples there. Okay? I can show you some examples. Let's proceed to this screen. Okay, let us see this graphic screen of Desmos. Okay, if we try y equal to a constant, then it will be displayed. Okay, for example, here you can type here y is equal to 1. There. Okay, you can see a red. You can see a red line here. Okay, that's y equal to 1, and it passes through 0, 1. Okay, it passes through this 0, 1 point here. Okay, so it's horizontal. If it's y equal to a number, okay, the number after the equals is equivalent to all y values in that particular line. Okay, let's have another example. Say y equals 3. Okay, y equals 3 here, the blue. So you can see it actually passing to 0, 3. And if we have another, let's say y equal to say negative 2, there you can see the green line, it's horizontal. It is horizontal. And you will notice all the points there will have all values, okay, with y values equal to that number. Okay, so a point here is 2, negative 2. A point here is 5, negative 2. So the y value is always negative 2 there. That's why the name of that line is y is equal to negative 2. Okay, so y equals negative 3. It's another horizontal, the violet line, and it passes through the intercept 0, negative 3. Okay, so this is how to write the equations when lines are perfect horizontal. Y equal to a number, and that number is the y-intercept. How about if the lines are vertical? All right, let me show that. If the lines are vertical, then it will be x equal to a number. Okay, say x equal to 2. there. Okay, it's perfect vertical. Okay, and it passes through the x-intercept to 0. Okay, where all points along this line will have x values equal to 2. Okay, all values of x here will be 2. Okay, let's have another example. Say x equal to 3. There. All values for x here along the red line will be, all points here will have a value of x equal to 3. Okay, vertical. X equal to -7. There, you can see the blue line, all the x values there, all the points there will have -7. All points here will have x values -7. Okay, so this is how to uh, write the equation of perfect vertical lines. Okay, x equal to a number, say -3 there. Okay, so this is how to write the equation for vertical lines. All right, so we know vertical lines and horizontal lines now. Okay, all right, let's go back to our other screen. Okay, so we're back to number 3, and as you can see, the given point is at 5, -3. The y value there is -3. So the value of the constant that we will use for y is -3. Okay, and the line will be of course like this. There, that's the line. Y is equal to -3. Okay, all right, that's it for the required answer, and that's it. Y is equal to -3. Let's continue with the next number. Let me just clear the answer and then proceed to the fourth. Okay, here's the fourth. All right, let's read the problem. What is the equation of the line that is parallel to the given line and has an x-intercept of -6? Okay, x-intercept of -6. That means the required line will have to pass through -6, 0. Okay, -6, 0. There. Okay, the required line will have to pass there. Okay, now write your answer in slope-intercept form. Okay, and slope-intercept form is of course y is equal to mx plus b. There. So this is y is equal to mx plus b. All right, write your answer in slope-intercept form. All right, how are we going to approach the solution? We have a given point, and we can label this our x1 and y1 like this. And we can actually make use of the 2 points, the red points that you see, to compute for the slope, okay? To compute for the slope. Now, one of the points is 6, 1, okay? 6, 1. One of the red points, that's 6, 1. The other one is along the y-axis, which looks like 0, -1, okay? 0, -1, there. All right, so we can make use of these 2 points and use the slope formula so that we'll be able to make use of the slope and then use it here. There, okay? All right, so by doing this, let's label first these 2 given points, the red points, and let's call this x1, y1, and the other is x2, y2. And then we will use the slope formula. All right, here is the slope formula. y2 minus y1 over x2 minus x1. Okay, compute now the slope first. y2 is 1 minus our y1 happens to be a -1. So after this minus, we will write -1. And then this is divided by, all right, let's get our x2. x2 is 6 minus, let's get our x1. That happens to be just 0. So this is now minus negative, that becomes plus. So we will have 1 plus 1. And this is divided by 6 minus 0, which will just give us just 6. So this is 2 over 6. And this is reducible to just 1/3. And we have the required slope. Okay, that's a 1/3. Now, we can now use this slope, okay, and this -6, 0. Okay, it says in the problem, the line will have to have an x-intercept of -6. X-intercept, not y, x-intercept. And so that point is -6, 0. We can use that point and the slope, okay? And we shall use a formula which is called point slope form, and use the point and use the slope, okay? All right. Now that we have the slope 1/3 and we need some space for the equation of the line, all right? So we will just erase this part. We can erase this part and then just denote the 1/3 our, of course, m, okay? This is our m here, all right? And then we shall use the point slope form first and then come up with the required equation here after doing some algebra, okay? You will have to transform it to that form, okay? All right, but first we will have to use the point slope form, okay? Let me write it, point and then slope, point slope form, okay? Let me remove the arrow here because this one is slope intercept, okay? Now the point slope form, okay, looks like this. Y minus y1 is equal to m times x minus x1. The x1, y1 happens to be the -6, 0 that we're about to use now, okay? All right, this point here, okay? This point here. All right, so using the point and the slope 1/3, this is now what we do next. Y minus y1, it's a 0. Okay, remember we're using -6, 0 now for the x1, y1. Okay, and this is equal to m, that's 1/3. Okay, because we're to follow this word here, parallel, should be parallel, so we will use the same slopes. Parallel lines have equal slopes, of course. So we will follow 1/3 times x minus x1. We are now going to use x1, which is -6. So after the minus in the formula, we have to write the -6. This is how to use the formula, like that. The rest will be algebraic simplification. So we're going to simplify now. Okay, this will now be y minus 0. That will just be y. And this is 1/3 times x minus negative is plus 6. Okay, like that. Then we will distribute the 1/3 and we shall be able to come up with the required form. Okay, so this will be y equals 1/3 x, and then 1/3 times 6, that's 2. Okay, that will be 2 because that's 6 times 1 over 3. Okay, so that will be 2. And so this is the required format. This is now the slope-intercept form, which you can compare right there, okay? And so this must be the answer, okay? This must be the answer. All right, so we shall see where the answer will be displayed. All right, let us check where the computer will display the answer. Let us verify our answer. Okay, it's right there in the negative 6, 0. So let's remove that particular given. Let me erase this part. I can see the answer there. All right, so this is the answer there. All right, so over here, you can see the answer over there. And that's exactly what we wrote over here. Okay, that's y is equal to 1/3 x plus 2. So what we did in number 4 is to compute for the slope first, okay, and then use the given point, which is given x-intercept of negative 6. That means it lies along the x-axis. So the y there is 0. That's why we use negative 6, 0. Okay, the points along the x-axis is a value 0 for y. Okay, so that'd be for our number 4. Let's continue with the next. Let's have number 5. Let's have number 5 here. All right, let's remove the answer and then proceed to 5. Okay, here's number 5. What is the equation in standard form? Take note of the form, okay? Standard, okay? Standard form. What is the equation in standard form? And standard form looks like this. AX plus BY equals C, where X and Y are variables and A, B, and C will be numbers. Okay, this is what you call the standard form. What is the equation in standard form of the line that is parallel to the given line in the figure and passes through the point -4, 2? Okay, -4, 2 is the blue point that you see. Okay, so we can see the red points there, which will provide us 2 points, and we can use those points to compute for the slope. And then we can use the slope and the point, okay, to come up with the equation. And then just transform it algebraically into this form, which is the required form, standard form. All right. So we shall begin with the slope. And the points that we have by inspection, we have a point at 0, 2. We have another point at 5, 0. There. And so we can use these 2 points to compute for the slope. All right, for a while, we're going to label these 2 points x1, y1, x2, y2, because those are the labels for the slope formula. So let this be 0, 2, let this be your x1, y1, and the other will be x2, y2 there. And then proceed to the formula. This is y2 minus y1 divided by x2 minus x1 there. Here's the formula. All right, let us now use these numbers to compute for the slope. This is now y2 is 0 minus y1, that happens to be 2. And then let's go to the denominator x2, that's 5, minus x1, that's another 0. So this will be reduced to -2 in the numerator and just a 5 at the denominator. So this clearly is like -2/5, okay? So this is -2/5. So this is the required slope, okay? This is the required slope. And so we now have the slope, -2/5. We shall now use the given point -4, 2 and come up with the equation, okay? All right, so we're done computing the required slope. Remember, we're after another parallel, so we will have to use the computed slope, -2/5, this computed value here. All right, we shall erase some parts of this because we will not be needing it anymore. We have the slope, okay? And so let's just remove this part. okay, and just label the negative 2/5 our slope, okay. This is now our m, okay. All right, now if you have a slope and a point, okay, we will have to use this formula, which is called point slope form, okay, point slope form. All right, and this is y minus y1 equals m times x minus x1. There, okay. All right, so this is the point slope form. We have to make use of the negative 4, 2. Negative 4, 2. That's the required point where the required line will pass, okay. So this will be labeled x1, y1, okay. All right, there. And so using this point and the slope negative 2 over 5 and this equation formula here, we shall be able to write the equation, okay. All right, so this variable y remains y minus y1. Our y1 is the 2. Remember, we are using this, okay, and this will be equals m. Our slope is negative 2/5, and this is times x minus x1. Our x1 happens to be a negative 4, so this is negative 4 there. All right, we will just simplify this and write this in standard form, okay, standard form. So this will now be reducible to all right, minus minus, let's start there. That becomes plus. So this will be equals negative 2 over 5 x plus 4. And the left side is still y minus 2. Okay, if we multiply both sides by 5, then we will be able to get rid of the fraction. So we multiply here by 5, and we multiply here by 5. There. And so this cancels out with the denominator. Okay. And then this will be reduced to, let's proceed to the left side, distribute the 5. This is 5y minus 10. Okay, a little algebra now. This is just negative 2 now. Negative 2 times x plus 4. Okay, that's what happened at the right side when it's multiplied by the 5. Okay, now you can distribute the negative 2 into the x plus 4. So this gives us negative 2x and negative 8 there. And the left side is still 5y minus 10. Okay, now after rearranging the terms here, negative 2x goes to the left side. It will become positive by transposition. And the negative 10 goes to the other side, okay, becoming plus 10, okay? All right, I'll show you that. This will become 2x plus 5y equals, all right, the 10 goes to the other side. That becomes 10. The negative 8 is still there, okay? We call that transposition. The negative 2x goes to the other side, becoming a positive 2x. The 5y remains there, so there's no change in the sign. The negative 10 goes to the other side to the right. From negative 10, it is now a plus 10. There's no sign anymore. That means it's positive. The negative 8 did not move at all from right, so it remains negative 8. Now, after simplifying this, we're going to have the required standard form. So this is now 2x plus 5y, and this is equal to 2 there. And this is the required standard form. You can see the ax plus by equals c there. And the a happens to be 2, the b happens to be 5, and the c is the constant after the equals. Okay, so the required answer is this. That's the required answer. All right, so let us see the answer. Okay, Let us see the answer. All right, it's down here. Okay, let me just shrink it a little bit. Okay, it's over here. There. 2x plus 5y equals 2. Exactly what we have over here. Okay, there. 2x plus 5y equals 2. That's the standard form uh, parallel line. Okay, so just remember the different types of forms. We have the standard, we have the slope-intercept, we have the point-slope form, which should be written this way if it's a requirement to write it point-slope form. It should look like the formula I have enclosed there. Okay, so just read the problem carefully. Okay, so this is in standard form, the number 5. Okay, all right, so just compare the answer and our answer. Okay, all right, that's it for number 5. Let's continue with the next. Let me clear the screen, and then here's number 6. Okay, here's number 6. Let's read. What is the equation of the line that is parallel to the line y minus 2 is equal to negative 3/4 times x minus 4 and passes through the point negative 4, negative 1? Write your answer in slope-intercept form. What is the equation of the line, okay, that is parallel to the line? Okay, let's write the given. This is the given. The given is y minus 2 equals negative 3/4 times the quantity x minus 4. There. And passes through the point negative 4 and negative 1. Okay. So write your answer in slope-intercept form. All right. Now, the given equation here takes the form point-slope form. Okay. Point-slope form. And we can readily see the formula there. Okay. Y minus y1 equals m x minus x1. And you can clearly see the slope. It's a negative 3/4. Okay, it's a negative 3/4. So the slope here, by inspection, it's negative 3/4. There. Okay. Now, we're asked to get the parallel line to this line. And the required line will have to use this negative 4, negative 1. So we're going to make use of this negative 4, negative 1 as our x1, y1 there. And we're going to use this formula. Okay, we're going to use this formula and use the negative 3/4. Okay, so this will now be y minus, so y1, our y1 will be negative 1, and this is equal to negative 3/4, negative 3/4, and then x minus x1. Our x1 happens to be the negative 4. There. Okay. Now we simplify and then write it in slope-intercept. Okay, that's according to the statement. Write your answer in slope-intercept. Okay, what I wrote here is the point-slope form. Okay, all right. So this is not the required. Okay, so we still have to simplify this. All right, so this will be simplified before we finalize it. All right, this is y minus negative 1. This will become plus y plus 1. All right, we have the slope negative 3/4. And then times the quantity x minus negative 4. So this will become plus 4. There. Okay. And so we have to simplify this into a slope-intercept. Okay. Slope-intercept. So we can distribute the negative 3/4 into the parentheses. All right, inside the parentheses, this will give us equals negative 3/4 x, and then that negative 3/4 multiplied by 4, that surely is just negative 3 there. Because negative 3/4 times 4, that's negative 12 over 4, okay, which is just negative 3. The left side will still be y plus 1. Okay, after simplification, we subtract 1 from each side. We subtract 1 from each side. And the result will be negative 3/4 x, okay, minus 1, minus 1. The number at the left will now be minus 4, okay, like that. Okay, and so this is now the final answer. This is the required slope-intercept, okay? The intercept here is the negative 4, and the slope is the negative 3/4. We shall be able to see the answer after a while. All right, let's see where the computer will display the answer. Oh, it's up there, okay? Right at the word given. So let me clear that word over there. And the box, okay, there. All right, hopefully you can see it there. All right, let's display it again. Okay, it's over here. There's the answer. All right, y is equal to negative 3/4 x minus 4. Exactly what we have in our computation there. Negative 3/4 x minus 4. All right, that goes to our number 6. Let's continue with the next. Let's clear the screen, proceed to number 7. Number 7. Here is number 7. All right, there's no graph, okay? All right, just wordings. All right, so let us read. What is the equation of the line that is parallel to the line 3x plus 2y equals 10 and passes through the point negative 4, 1? Write your answer in slope-intercept form. All right, the given line is in standard, okay? It looks like in standard because this looks like this. Ax plus by equals c, okay? And this is 3x plus 2y equals 10. There, okay? So what is the equation of the line that is parallel to this line and passes through the point negative 4, 1? Okay, negative 4, 1. So we have a given point, we have a given line. We're asked to get the line parallel to this given line, but will pass through this point, okay, negative 4, 1. So how do you approach the solution? We will have to get the slope from the given equation, okay? We will have to determine the slope. All right, so an easy way to do it is to transform it to slope-intercept, okay? And this is how to do it. All right. Subtract 3x from both sides, okay? So this we do it here. 3x plus 2y. Let's put a space there. Let's put the 10 away over here. And that's a positive 10, right? Like that. All right. So a little bit of arrangement like this. We subtract the 3x, okay? So that the x term and the y term isolates from each other. So we subtract the 3x. There. And then we subtract the 3x. There. Okay. And so this 3x cancels out with the 3x. 3x minus 3x. And so the left side will now be just 2y and then equals, we now have the right side, negative 3x plus 10. Like that. All right. We're almost there. Now we have to divide by the number 2. All right, divide both sides. So this will be dividing by 2, dividing by 2. and the 10, like that. Okay, all right. And after which, left side is now y equals negative 3 over 2x plus 5. And you can readily see the format. This is now in slope-intercept form, okay, of the given line. Okay, this is just to get the slope. Okay, you can very well see the slope. It's the negative 3 halves there. Okay, because this is now in this form. There. So we finally have the slope, which is negative 3 halves. And that's what we need, okay? That's a negative 3 halves. We need this slope. And we will be using this with this point, okay? And after which, we'll be able to get the required equation, okay? All right, so let's do that. Let me just remove the checks. And then this is now x1, this is y1, there. All right. Now, if we have a slope and a point, we will have to make use of the point slope form. And then just use algebra to transform it to the required slope intercept. Okay. All right. And slope intercept form is this form here. Okay. All right. So first we use this slope and the negative for 1. All right. But our formula to be used right now is the point slope form. And let's start there. So this is y minus y1 equals m times x minus x1. There. Okay. And so this is y minus y1. Our y1 is 1. This is equal to m. This is negative 3 halves times x minus x1. Our x1 is negative 4. So after the minus in the formula, we still have to write negative 4 there. Okay, so we will simplify this and convert it to the form here. Okay, that's the required form, slope intercept. This form here, as I was saying, this is the point slope. Okay, all right. Okay, let's simplify first. This is y minus 1. This is equal to negative 3 halves times the quantity x minus negative is plus. So this is plus 4 like that. All right, let's distribute the negative 3 halves inside the terms of the grouping symbol. So that should be negative 3 over 2x. And that will be, how much is that? 12 over 2, that's 6. Negative 6. Okay, and then we still have the y minus 1 there. All right, if we are going to add 1 to both sides, okay, add 1, okay, you add 1 and then add 1 here, then the left side is now just y equals negative 3 over 2x negative 5. And that should be our final answer. Okay, that should be it. That should be the final answer. And it takes this form already, the slope-intercept form. Okay, it takes this form, slope-intercept form. You can see the format. Y equals to a number times x plus another number. That negative 5 means plus negative 5. So that is reducible to just minus 5. So that should be our answer, and let's find out. Okay, it's displayed over here in the formula that I wrote. So we're going to clear something. Let me clear this formula here and the given. All right, and the answer will be displayed over there. Okay, all right, it's over here. Okay, exactly what we obtained. Okay, negative 3 halves x minus 5 at the right side. Okay, and that means this is correct. There. All right, so this is how to write equations. You have to make use of the given, okay, the given data, the given conditions, okay, and so and use the forms that you have studied, okay, and there are several forms: slope-intercept, point slope, standard, okay. There's also 2-point form, okay, 2-point form. All right, so let's proceed to the next. Let's have number 8. Let me just remove the answer. And then next, all right, here is number 8. I believe we discussed something like this a while ago in the Desmos screen. What is the equation of the line that is perpendicular to the given line, okay, and passes through the point 5, 5. All right, I believe 5, 5 is the red point, okay? That's the 5, 5. You can see it. It's 5, 5. So we're looking for the equation of, okay, we're looking for the equation of this line. We're after that line, okay? Perpendicular to the blue line, that must, if the blue line is perfect horizontal, then the perpendicular line to it is a perfect vertical, okay? And we discussed a while ago, the blue line, we will use the y value, okay? All right, so for the blue line, okay, for the blue line, you name this y equal to the y values there, okay, which is a constant at -3, okay? All right. Now, we're asked to write the equation of the line, the vertical line, okay? Now, to get that, it will have to be x, okay? For vertical, it will be x. So that will be x equal to the number for all x values there. And that will be, of course, 5, okay? That's the required answer. That's the required equation for this line, okay? So x equals 5, all right? So this is the answer, all right? Let's verify. So let's make it smaller. I think it's down below the graph. There, okay? It's over here. X equals 5, okay? All right. I hope you did not forget the discussion a while ago. I shrink the screen so the line shifted, okay? The drawing shifted, all right? Let me just redraw it. There, okay. That's the x equals 5. All right, that's it. So just remember, if the lines are vertical, it's x equal to something, okay? If the lines are perfect horizontal, it will be y equal to something, all right? Don't forget that. All right, let's continue with the next number. Let's proceed to number 9, okay? Let's proceed to number 9. All right, here's number 9. All right, let's read the problem. What is the equation in point slope form? Okay, point slope form. How does a point slope form looks like? The point slope form looks like this. Y minus y1 equals m times x minus x1. Okay, this is what you call the point slope form, where you can see the point x1 and y1, those are numbers, and the m, that's another number. Okay, and the x and y remains letters, okay? And that's what you called point slope form, where after the answer that looks like this, okay? What is the equation in point slope form of the line that is perpendicular to the given line, okay? And passes through the point -5, -4. So by looking at the graph, you can see the blue line containing 2 points, okay, which we can actually read. So we can get from those 2 points the slope, okay? And then the other point not on the line, that's the -5, -4, okay? Yes. -5, -4, the third quadrant. Now, we're asked to get the equation of that perpendicular line to the blue line. So once we have the slope there, we still have to get the negative reciprocal, okay? And that's what we're going to use with the -5, -4, okay? All right, so let's uh, let's come up with the slope first, okay? The slope from the given line, okay? All right, so let's compute, okay? Let us compute for the slope first. Now, before we can do that, we have to get the coordinates of the two given points. All right, one of the points by rating, that's -2, 1, okay? All right, -2, 1, and that's located at the second quadrant. The other point is on the y-axis. It looks like 0, -4. There. And by using these 2 points, we shall be able to compute for the slope. Okay, we shall be able to compute for the slope and then get the negative reciprocal of that. Okay, because that will make it perpendicular. All right, so let's get this slope first of the blue line. Okay, so this is, we can denote these are x1, y1. These are x2, y2 there, and then continue to compute for the slope first. Okay, all right, so the same formula, y2 minus y1 divided by x2 minus x1. All right, and this must be equals, our y2 is -4 minus our y1, that happens to be just 1. Going to the denominator x2, we have 0 minus our x1. All right, that happens to be a -2. There. All right, so this will be reduced to -5 over +2. Okay. -4, -1 is a -5 divided by minus minus, that becomes plus. So we have a -5 over 2. So our slope is -5/2. All right. This is the slope of the blue line. We need the slope of the perpendicular. So the -5/2 becomes a +2/5. Okay. We need the perpendicular to this. That's the reciprocal, and the sign is reversed. So from negative, it is positive, and then the 5/2 becomes 2/5. Reciprocal, okay? All right, everybody knows how to do that, of course, at this point, okay? Reciprocal. Interchange the numerator and denominator, okay? All right. So also, it's negative reciprocal. So from a negative, it will become positive, like that. If it's coming from a positive, it will become negative, okay? Always reverse. Okay, you reverse the numbers, you reverse the sign as well. Okay, all right, so this is the required slope of the perpendicular. We're now ready to use the given point -5, -4. Okay, all right, let's erase something. We don't need the other writings at this point, so we will be erasing it. All right, we already have what we will use in the required perpendicular. All right. Okay, we need this slope now, 2/5, and the given. All right, the given is the -5, -4. Okay, there. All right. This line will have to be something like this, just to approximate it. All right, it will have to be going like that. Okay. That's why the slope of that is a positive. We can surely see that here. It's a positive slope. Okay. All right. So let me erase that line. Okay. It's just an approximate line. All right. Okay. So we shall continue with the labels. Okay. label it x1. This is now our x1 and y1 there, because we will use it in this formula. Okay, remember, we have to write it in point slope form. Okay, all right, so let us start. This is now y minus y1. This time our y1 is the -4. And this is equal to m, that's 2/5 times the quantity x minus x1. All right, it's a -5. After the minus, it's a -5. There. All right, simplify it. This will be y minus minus becomes plus, and this is equal to 2/5 times the quantity x, another minus negative, that becomes plus 5. There. Remember, we have to write it in this form, so this must be the answer. Okay? There. What is the equation in point slope form? This is the point slope form. All right, so that's it. All right, let us see the answer. All right, let us find out where the computer will display it. Oh, it's over there in the formula. It's over here in the formula. So let me remove that. All right, let me remove that. Okay, let's see the answer there. Okay, it's there. There is the answer. All right. Y plus 4 equals 2/5 times x plus 5. Exactly what we have. So this must be the right answer. All right. Okay, that goes to our number 9. Let's clear. Continue with the next number. Number 10. Here's number 10. Here's number 10. What is the equation of the line that is perpendicular to and has the same y-intercept as the given line? The same y-intercept. So we will be needing the y-intercept of this blue line. And it looks like at 0, 2. Okay, so we're going to use the point 0, 2. There. Okay, so that is actually the y-intercept of the blue line. Now, write your answer in slope-intercept form. Okay, what is slope-intercept form again? That should be y equal to mx plus b. Slope and the intercept. Okay, write your answer in slope-intercept form. What is the equation of the line that is perpendicular to and has the same y-intercept as the given line? All right, before we can do anything, we only have the point 0, 2. We need the slope perpendicular. So first we get the slope of the blue line by inspection. All right, it looks like a negative 1/4. Okay, negative 1/4. Okay, how did I get that? All right, I'll show you. All right, that should be like if I get a point here. Okay, like that. That's 1 unit. I'm going to create a right triangle. A right triangle. So that's a vertical distance there. That's 1 unit, and then that looks like 4 units. And the sloping looks like sloping downward to the right. That means negative. Okay, remember, it slopes downward to the right, so it's negative 1/4. Okay, you can always draw another triangle over here. That's 1, and then 4 units there. 1, 4. Okay, 1, and then 4. Okay, so it's a negative 1/4. Okay, the slope of this, the slope of the blue line is negative 1/4. Okay, all right. Let me remove now the triangles. Okay, let me remove the triangles. All right. Okay, Now, we're after the slope perpendicular to this slope. That should be a positive, okay? That must be a positive. Positive, and 1 over 4 is 4 over 1, okay? Which is just 4 over 1 is just 4, okay? So we're going to use this slope, okay? All right. And then make it pass to the same 0, 2. The 0, 2 is this point. That's the 0, 2 there. The same y-intercept. All right. So that means we have the slope 4, and that's for the m, okay? And the b, the y-intercept is 2, okay? And we can now use this, okay? Slope-intercept. This must be written y is equal to m, that's 4, times x plus 2. That's it. That's the answer, okay? This must be the answer. Yeah. All right, so we shall see the computer's answer. All right, it's down there, so we shall shrink it. All right, it's down there at the bottom. All right, okay. A little bit of shrinking the display will show us there. Y is equal to 4x plus 2, okay? And that's it. We were able to determine the answer. It's y is equal to 4x plus 2. That's the required perpendicular to the blue line, okay? Perpendicular. If you're asked to draw it, then you shall be able to draw that as well, okay? All right. So how do you draw that line if you're asked to draw? It has a slope of 4, so that must be something like passing here, like that. It has a slope of 4. There, okay? 4. And where did you get that 4? Well, it's over here. You can draw it like that. That's 4 over 1, like that. 4 over 1. Just one unit there. 4 over 1. So the vertical is 4 and the 1 is horizontal. Okay, and it's a positive, okay, because the line slopes downward to the left. Okay, we already studied that in graphing. All right. Okay, so this is how to do it. All right, let me remove the triangles. All right, there. Okay, so this is how to write the equation, and this goes to our number 10. All right, so the answer is y is equal to 4x plus 2. Let's continue with the next number. Let's continue with the next number 11. All right, here's number 11. The given line segment has n points. All right, the red points, okay, the end points. And those points are negative 4, 5, and negative 8, negative 1 at the third quadrant. Negative 4, 5 is at the second. Okay, just see the graph, okay? You'll be able to observe negative 4, 5, that's the upper red point, and the lowest red point is negative 8, negative 1. We have another point. The midpoint at negative 6, 2. That is also located at the second, negative 6, 2. All right, what is the equation in slope-intercept form? We're required to write it. Y is equal to mx plus b. Okay, this is the slope-intercept form. Okay, what is the equation in slope-intercept form of the perpendicular bisector? Okay, perpendicular bisector of the given line. So we are supposed to find the equation, all right? And it must be like a line which will proceed this way, like that, okay? Supposed to be like that, okay? All right. So let me remove that. Okay, what is the equation in slope-intercept form of the perpendicular bisector? Okay, the one that divides it, bisector. So it must be the line passing to the midpoint. Okay, it must be the line passing through the midpoint. Okay, all right. So approximately it should be this line here, like that. Okay, it cuts the segment at the midpoint. Okay, bisector, perpendicular, that means it is at right angles to the blue line. Okay, blue line segment. Okay, all right. So how shall we approach the problem? All right, we need a point and the perpendicular slope, of course. All right, we don't have to find the midpoint, it's given. All right, we only need to get the slope. Okay, all right. And then after getting that, we can proceed to the formula point slope form. Okay, all right. So let us have the slope first of the blue segment and then get the negative reciprocal. And then that's what we will use to the red line. Okay, the required perpendicular bisector. Okay, the equation of that. Okay, all right. So let's start with the given and compute the slope. All right. So we have to use the negative 4, 5. Okay. And negative 8, negative 1. These are the endpoints. Okay. There. Negative 4, 5, and negative 8, negative 1. So this is x1, y1, and this is x2, y2. There. Okay. All right. So this is something we need to compute first and then get the negative reciprocal. Okay. All right. So let's use the same slope formula. This is y2 minus y1 over x2 minus x1. There. All right. So this will now be y2. This is negative 1 minus our y1 is 5. And x2 is negative 8 minus, all right, x1 happens to be another negative. So after the minus, it's a negative 4. There. Okay. All right. Y2. Let me just verify it. Y2 is negative 1 minus 5. Yes. And then at the denominator, x2, that's negative 8 minus the x1 is a negative. All right. So minus negative 4. All right. Simplify this. This adds up to negative 6 divided by negative 8 plus 4. And finally, this is negative 6 over negative 4. Negative by negative is a positive. It's a positive reducible to lowest term 3 halves. There, okay? And this is the slope of the blue segment. We need to get the negative reciprocal. That will be used in the bisector. So the reciprocal is 2/3, and from positive, it's negative, okay? So the required slope perpendicular to the blue line is a negative 2/3. There, I wrote it in the corner, okay? So it's a negative 2/3. All right, you know how to get that already, of course. Okay, now we will be needing this negative 2/3 and midpoint. Okay, the rest we can erase now. Okay, all right. So let's erase now the data here. All right. Okay, erase first so we can write the equation. Remember, we're asked to get the equation of the red, okay, the bisector. All right, what we need to use is this negative 2/3 and the midpoint. The midpoint is negative 6, 2, also the second quadrant. This will now be our x1 and y1. And we will use it in the point slope form. Okay, and that equation is y minus y1 equals m times x minus x1. And this m is now the perpendicular, okay, the one at the corner. And the x1, y1 is the negative 6, 2. All right, direct substitution and then simplify it. Simplify it to a slope-intercept, okay? It's over here. All right, what is the equation in slope-intercept? Okay, all right, slope-intercept happens to be that one. Okay, all right, so we will use this point slope, but we will convert that to this form. Okay, so let's use the numbers. Y minus 2 equals negative 2/3 times the quantity x minus negative 6. There. And so we will just simplify this. Y minus 2 is equal to negative 2/3. This is now x plus 6. All right, so let's distribute the negative 2/3. This will be negative 2/3 x, and then this will be a negative product of 2/3 and 6. So 6 cancels out with a 3. That gives us a 4, okay? That's 12 over 3. So that's a 4. And then the left side is y minus 2. So we will just add 2 to both sides. Add 2 and the left side will just become y. And right side, we will have negative 2/3 x. If we add 2 to the negative 4, it will now be just a negative 2 there. All right, we added 2. And negative 4 plus 2 is a negative 2. This must be the required slope-intercept form of the perpendicular bisector. All right, let us see the answer. It's over in the formula. Let me remove that formula. It's right there. All right, it's here. Okay, there. So y is equal to negative 2/3 x minus 2. Exactly what we computed there. All right, that goes to our number 11. Let's have the last number, number 12. I hope you were able to understand the solution. Let's proceed to the next. This is our last number, okay? Our last number. All right, we don't have graph here, okay? So let us just read the problem, okay? All right, a given line has the equation x plus 4y equals negative 4. That looks like standard, okay? ax plus by equals c, okay? All right, where x and y are together at the left side, that's standard. All right, what is the equation in slope-intercept form? Let's write that requirement, okay? What is the equation in slope-intercept? So it must be like this, okay? Slope-intercept. All right, what is the equation in slope-intercept form of the line that is perpendicular to the given line and passes through the point 0, 3? Okay, perpendicular to this, okay? And passing through 0, 3. All right, so just use your imagination, use the given, determine the slope from the given equation, and then get the negative reciprocal of that, and that's the slope that we're going to use with a 0, 3. Okay, all right, that's the way to get the answer. Okay, a given line has the equation x plus 4y equals negative 4. All right, so let's get the slope first. So this is now x plus 4y equals negative 4. All right, how shall we determine the slope here? We will transform it to this form, okay? And we will investigate where the m is located. And that's it, that's the slope, okay? All right, so first we will isolate the x. So we subtract x like this. Let's put a space there. Let's move the negative 4 a little farther from the equal sign. All right, here's what we do. There's an x at the left side. If we subtract x here, that cancels out with the other x, and we shall do the same like that. And so the left side will just become 4y. And the right side is now negative x minus 4. All right. Okay. Now, if we can make the left side just y, then it will take this form. And we can find the m. All right. So we divide this by the 4. And divide each of the terms by the 4, like that. And so this will be reduced to y equals to negative 1/4. That looks like negative 1/4 x minus 1. All right. There's the given equation, and we can clearly see the slope is negative 1/4. Okay, negative 1/4. All right. So m is negative 1/4. If we're after a parallel, then we will use the negative 1/4. But we're asked to get perpendicular to the given line. Okay, that means we have to get not 1/4, it's 4/1, which is just 4. Okay, so the slope perpendicular is just 4. Okay, 1/4 is 4/1, and 4/1 is just 4. And from negative, we will have the positive. Okay, so this is our required perpendicular slope. All right, so we will not be needing the computation here. All right, we will only need the slope 4 and the 0, 3. Okay, so we shall erase some of this. Okay, all right. So we shall erase this. Okay, all right. Okay, all right. We can now use the 0, 3 and the 4. Okay, all right. Let's continue there. This is now 0, 3. It must be passing through the point 0, 3. This will now be our x1 and y1 there. And we shall now use a point and a slope. Okay, so we are back to this formula. Y minus y1 equals m times x minus x1. And then use the data that we have. So direct substitution now, y minus 3, that's our y1, equals m, that's 4, times the quantity x minus x1, that happens to be just 0. All right, remember, we're using this, okay? All right, so just simplify it. The right side, we distribute the 4, so this is 4x, and then 4 times 0, that's just 0, so we don't have to write it. And the left side is still y minus 3. Okay, after adding 3 to both sides, this will now be y equal to 4x plus 3. And so this one looks like that, okay? And that is the slope-intercept form. All right, so this is it. All right, slope-intercept form is the required format, and let us see the answer. It's over here. There. y is equal to 4x plus 3. Okay. All right. So we're correct up to the last number. So I hope you were able to learn something about equations of lines, parallel and perpendicular. All right. And I hope you were able to get how to do it. So see you later and goodbye.